tell me something you remember about right triangles from geometry. Or maybe SAT that you took, or ACT. What works in a right triangle? Come on, you got to remember something, especially those of you who took a standardized test. What works in every single right triangle? All right, let me help you out. There we go. Okay, so this is A, this is B, this is C. What's the name of C? What do we call that? Hypotenuse. So you do remember some stuff about right triangles. All right, C is the hypotenuse. And what works in every right triangle is the relationship A squared plus B squared equals C squared. All right, Emma, you came up with that. What's that called? Don't remember. Okay, so remember that. You remember that's what it does start with a P. Okay, this is the Pythagorean theorem. Pythagoras was a Greek mathematician, and he came up with this relationship that if a triangle has a right degree, has a right corner, a 90-degree angle, then the relationship between the legs, A is one leg, B is the other leg, and C is the hypotenuse, would be true that A squared plus B squared equals C squared will always work. All right, so let's do a couple examples of that. And so what that allows you to do is to find the missing side of a triangle. So if you're given A to be 5, C to be 13, then you should be able to find B, if you know that it's a right triangle. And so using the relationship, we would say that then 5 squared plus B squared equals 13 squared. And that's just a simple formula to evaluate. So 25 plus B squared is 169. And then you subtract 25 from both sides. And when you subtract 25, you get 144. And so what would the value of B need to be based on that equation? How do you get that? Well, it has to be in front of every square root. Okay, so it's plus or minus 12. All right, now you might be wondering, well, what do you mean a minus 12? How can a side be minus? We'll talk about that tomorrow, but I do want you to just be aware. Don't forget that the rules about pluses and minuses are still same as last semester. What goes always in front of a square root would be a plus or minus. Okay, let's do another example. So another right triangle might have a different set of values. So perhaps you might be given, this time we know B is 4, and C might be 9. So then that leaves A as the unknown side. And since it's a right triangle, it's true that that relationship would still work. So then we would have A squared plus 4 squared would be equal to 9 squared. And that simplifies to A squared plus 16 equals 81. And then again, we're going to subtract on both sides. And so A squared would be equal to 65, which is what you get when you subtract 16 from both sides. And then A would be the plus or minus square root of 65. Now maybe you could simplify that square root. 65 doesn't happen to be something that can be simplified, so you leave it like that. But if it was, say, the square root of 50, well, then you would have to simplify that. Okay, so that's one thing that's true about the three sides of a right triangle. But not only does a triangle have three sides, what else does it have besides having three sides? It has three angles. Yeah, angles. Okay. All right. And so this is what we're going to do. So we've got side A, side B, and side C. The angles, well, we know that one is 90 degrees. And then usually in trig, we use Greek letters to stand for angles. Things like theta, lambda, gamma. Okay? The Greek letters I'm going to use here are going to be alpha and beta. Okay, alpha looks like this. It's like a sideways 8 that's not quite closed all the way. That is alpha. And when you use a Greek letter, then it means an angle. And then beta is like a capital B with a long tail. and that's the value for beta. And those represent angle measures. And we already know that the right angle is worth 90 degrees. By the way, how much are all the angles in a triangle worth if you add them all up? I heard it. 180. Okay? All right, so we know something about all the sides, that all the sides, when you add them up, a squared, b squared equals c squared. All the angles, if you add them up, would be equal to 180. And then all of those things together are going to be what's called SOHCAHTOA. Other Greek letters you might see look like this. That's the Greek letter theta, so that might be in a corner sometime. You might see gamma. You might see mu, which is like a U with a long tail coming up. Okay, there's lots of different Greek letters, but just remember, all you need to know is that the Greek letter means that you're talking about an angle, not a side. We use regular letters to talk about sides. We use Greek letters to talk about angles. Okay, so that leads us to SOHCAHTOA. SOHCAHTOA, S-O-H-C-A-H-T-O-A. SOHCAHTOA is a funny little made-up word that helps us remember the three relationships of a triangle. They are sine, cosine, and tangent. That's where the S in SOHCAHTOA comes from. It's where the C in SOHCAHTOA comes from. It's where the T. All right, sine is found by placing the opposite side over the hypotenuse side. Okay, I'm actually going to write that a little smaller. Okay. Opposite over hypotenuse. Okay, so what do I mean by that? What do I mean by opposite over hypotenuse? Okay, so let me give you an example. Let's look back at the picture again. If I say sine parentheses alpha, and when we are doing it, we just abbreviate the first three letters because we don't need to write it all out all the time, so we drop off the E and we write sine. If I'm asking you for the sine of alpha, you go to the picture, you find alpha, and then you look at what is directly opposite or across from alpha. And what's directly across from alpha, if I look across here, is side A. So the opposite, or the across, is side A. The hypotenuse is side C. So it is A over C. That's what I mean by opposite over hypotenuse. But if you switch, and you say, well, what would sine beta be? Well, then if you're going to do sine beta, you got to start in the beta corner, and you got to look at what's opposite beta. And what's opposite beta is side B. And so its opposite would be B over the same hypotenuse, which is C. So it's always the side opposite of what you're looking for if you're asking for sine. Okay, I'm going to erase these little arrows I drew. Okay. All right, then we move on to cosine. All right, cosine is adjacent over hypotenuse. The word adjacent means next to. Okay, to be adjacent to something is to be right next to it. And so the word adjacent tells us to look at the side that's next to it. So if we do the same thing, if we say, okay, well, according to my picture, what is cosine alpha? Then you start with what's right next to alpha. Well, there are two things next to alpha. One of them is B, and one of them is C. And if I look at what's next to both of them, okay, B and C are next to both of them. Well, which one do I choose? Well, you never choose the hypotenuse, because the hypotenuse is special. The hypotenuse is going to be on the bottom. It's going to be C there. And so you choose what's next to it, which would be B, and so that would be B over C. Where else have we seen B over C? Where else do you see it? Sine beta, right. Sine beta and cosine alpha happen to be the same thing. We can do cosine beta as well. And so adjacent to cosine is side A, and the hypotenuse is still sine C. So notice they switch places. And then you've got tangent. And tangent is TOA, which means T-O-A. And so the O stands for the opposite, and the A stands for the adjacent. You've done all of this in geometry. I know my daughter took geometry last year, so I remember watching her do it. And so a tangent would be opposite over adjacent. And so then if you're going to ask for any corner, you're going to ask for the tangent of the alpha corner. You start with the opposite, which was A, and you go over the adjacent, which is B. So the one that's left out is C. We don't use C at all in tangent. And then the tangent of beta, B with the tail. Okay, that'll be the opposite, which is B, over the adjacent, which is A. And again, I don't use C at all. That's what SOHCAHTOA is. Okay, so SOHCAHTOA is a weird made-up word just to help you remember the order in which sine, cosine, and tangent go. So the SOH stand for sine, opposite, and hypotenuse. That's what the O and the H stand for. O is for opposite, H is for hypotenuse. Cosine, C-A-H. Cosine is cosine, adjacent, hypotenuse. And then tangent, TOA, T for tangent, O for opposite, H for adjacent. Okay, any questions so far? Anything you're wondering about? I did alpha and beta. What did I not do? How many corners are there in a triangle? 3. I only did alpha and I did beta. Which one did I leave out? The right angle, the 90-degree angle. Okay, we never are going to use the 90-degree angle for sine, cosine, or tangent. Okay, it's always one of the other 2 corners. So, no questions on that so far? All right, well then let's practice and see how well you're understanding. Okay, so we're going to start with a right triangle. Example A. A is 3, little a is 3, little b is 4, little c is 5. So it helps me to draw them. Okay, if A is 3, then I'm going to put 3 here. B is 4, 4 goes on the bottom, C is 5. And then I'm going to put my Greek letters, alpha down here, and beta up in the corner. And your job would be to find sine, cosine, tangent for those values. Okay, so let's start with alpha. We'll keep it simple at the beginning. We're going to do sine of alpha. We'll do cosine of alpha. And we're going to do tangent of alpha. Okay, does anybody want to try sine? Sine is opposite over hypotenuse. Okay, let me see. Hypotenuse. Which one's the 3 over 5? Very good. So you got the opposite right. That's 3, and the hypotenuse is over 5. Okay, so opposite over hypotenuse. Okay, good. Daniel, oh shoot, I should have had my 2 Daniel B's split up. Daniel, that's wrong. Okay, you want to try cosine? Adjacent over hypotenuse. 4 over 5, yep. So we really only have one other combination that we haven't done yet. Christina, how about tangent for you? Opposite over adjacent.
I'm sorry, 3 over 4.
Perfect. Okay, any questions on those 3? Okay, then we have 3 more. The 3 other ones we have are something called cosecant, secant, and cotangent. Cosecant, secant, and cotangent. We'll start at the bottom. Cotangent. The abbreviation for cotangent is COT. So what is COT alpha? COT alpha is the reciprocal of tangent alpha. So tangent alpha that Christina just found for us, cotangent of alpha is the reciprocal, so 4/3. So all you gotta do is flip it and you're done. Okay, let's work our way up. Secant, the abbreviation for that is SEC. The secant is the reciprocal of the cosine. And so that would be 5/4. Then we get to the last one at the top. I saved this for last. What do you think the abbreviation for this should be? Okay, if I took the first 3 letters, like I do for all the other ones, it would be COS. What's the problem with that? We've already used that abbreviation, so COS doesn't work. So we have to come up with a different abbreviation instead, and so the abbreviation for that one is the first 3 consonants, which are what? CSC, right? We skip the vowels, which are O and E, so it's CSC. Okay, that is cosecant, and the cosecant of alpha is the reciprocal 5/3. So I always do my first 3 first. I do SOHCAHTOA first, and then I do my other 3, and I just flip. Okay, so there are 6 total in triangle trig. There's the 3 originals, and then there's the 3 reciprocals. Okay, any questions so far on that? Okay, let's try another one. Okay, example B. This time, A is unknown, B is 3, and C is 10. So before we can do anything, we've got to figure out the unknown side. Because all we have is 3 and 10. So what can we use to figure out the unknown side? Say it again, Kara. All right, I'm going to use the Pythagorean theorem first, before I do SOHCAHTOA. So both things that we've learned. So the Pythagorean theorem tells me, all right, a squared plus b squared, so that's 3 squared, equals 10 squared. So a squared plus 9 equals 100. Subtract 9 from both sides. A squared is 91. So A is the plus or minus square root of 91. On our triangle, we're going to label that as, because it's going up, it's going to be positive square root 91. We'll have other triangles that are going to be upside down. Those will be the negative ones, but we'll do those tomorrow. Okay, this will be square root of 91. So first I have to get all 3 parts. Then I can do sine, cosine, and tangent. So let's do the beta corner this time. So we want the sine of the beta corner. All right, Caden, you want to try it? Opposite of beta, and then hypotenuse of beta. 3/10. Perfect. Okay, Fraley, can you do the cosine of beta? So cosine would be adjacent to beta over the hypotenuse. Square root of 91, which can't be simplified, over 10. Okay, and then the tangent. Peter, you want to try the tangent of beta? Which is opposite over adjacent. That would be the tangent of the alpha corner, I want the tangent of the beta corner. So I have to start with beta, which is the opposite. So I need to go opposite, which means I start with 3 first. And then the square root of 91 on the bottom. So I always do my SOHCAHTOA first, and then I do my other 3. Okay, so once I have those done, then I go, okay, well then I should do CSC, and I should do SEC, and I should do COT. Okay, that's cosecant, secant, and cotangent. And those go really fast because I just have to flip the ones that I had. So that'll be 10 over, excuse me, 10 over 3, 10 over square root 91, and square root 91 over 3. And it is okay to leave square roots in the denominator. You don't have to worry about rationalizing. It's totally fine to leave those square roots right there. Okay, example C. Given cosine of theta equals 5 over 11. Find the other 5 trig values. All right, so given that cosine of that equals 5 over 11, find the other ones. All right, so you're going to want to start by drawing a triangle, and this time it says cosine theta. Theta is spelled T-H-E-T-A. Theta, not theta with a S. That's a cheese. This is theta, okay? When it's theta, you can put it wherever you want. Alpha always has to be on the bottom. Beta always has to be on the top. Theta can go either way. It doesn't matter where you put it, but you can't put it in the right corner. So you can choose. So you can put it here, or you can put it wherever you want. And we are supposed to find what sine of sine of theta is. We know what cosine of theta is, and we need to figure out tangent of theta. And then we have to figure the other 6 of them also. SEC and COT. Okay, I'm going to fill in 5 over 11 because I already know that one. I got to find the other 5. What's the easiest one to find first? If I got to find the other 5, what one would you find first, next? Yeah, shoot, I'd find SEC, because you know if that one's 5 over 11, then this one's got to be 11 over 5. I'd also go to my triangle. If I know it's 5 over 11, cosine is adjacent over hypotenuse. So what does that mean the hypotenuse has to be? 11. And what does it mean the adjacent has to be? 5. Which means now you're going to have to figure out the missing side of the triangle. And so you're going to need to figure out 5 squared plus b squared equals 11 squared. That's 25 plus b squared equals 121. And then you minus on both sides. So we get b squared equals 76. 76. No. 96. There we go. And so then b is the plus or minus square root of 96. Now here's one that can be simplified. 96 has a perfect square in it. It's square root 4 and square root 19. And square root 4 and square root 19 is square root 2 square root 19. This is going to be the positive one again, so 2 square root 19 is going to be the bottom. So that lets me fill in the rest of the trig values. I now can do opposite over hypotenuse. The opposite is 2 rad 19. The hypotenuse is still 11. Once I have that one, I can flip it, and I can do 11 over 2 rad 19. And then for tangent, I want opposite over adjacent, which is 2 rad 19 over 5. So then cotangent would be the reciprocal of that, which would be 5 over 2 rad 19. Okay, any questions so far? I've got one more example. Okay, last one. Example D. Find the value of x. All right, last right triangle. What corner is the 34 degrees in right now? Alpha corner. Okay, what side is the 15 on? Adjacent. Okay, no, opposite. So, opposite of 15, or on the A side. And then what side is the x on? So what uses alpha and opposite and hypotenuse? What formula? What uses alpha? Opposite. Very good. Sine uses alpha, and that would be opposite over hypotenuse. So we can plug in what we've got. Sine alpha is 34. Opposite is 15. Hypotenuse is x. Now you might stare at that a little bit and go, I don't know what to do next. But if you watch me do one thing, I think it'll trigger in your brain what you're supposed to do. If I draw a line under that and do a 1, what are you supposed to do next? There we go. Okay, so we're going to cross multiply. So we're going to cross multiply the x across to the sine of 34 degrees. And I'm going to cross multiply the 1 to the 15. And I'm trying to find the value of x, which means I need to get x alone. So what should I do to both sides to get x by itself? Divide, right. So x equals 15 divided by the sine of 34 degrees. Now, I had you get your calculators out so you could do that. Could you type that into your calculators for me? 15 divided by the sine of 34 degrees. And if your calculator's already in degree mode, you just type 34 and then parentheses. Okay, Isabel, what'd you get? Okay, Emma, what'd you get? All right, let's go to 3 decimals. So 26.824 is the answer for x. And x stood for the hypotenuse, so now we know how long the hypotenuse is. We have time to do one more of those. I think I'd feel a little bit better. I wasn't sure if we'd have time for a second one, but last one, I promise. All right, so find the value of z. And it's going to be okay if you have a backwards triangle too. Okay, z is going to be up here. (23) is going to be right there. And 39 is going to be up in this corner. All right, so what corner is the 39 in? Okay, that's in beta. What do you call the 23? What side is the 23 on? It's on the adjacent side. It's next to beta, and z is on hypotenuse. So what uses beta, adjacent, and hypotenuse? What uses those 3 things? Cosine, right. So cosine uses beta, adjacent, and hypotenuse. So then you plug into that formula. So cosine of beta, which is 39 degrees, equals adjacent, which is 23, over hypotenuse, which is z. And then this is another chance for you to cross multiply. So you'll drop the 1 underneath. You'll cross multiply again. So z cross multiplies to the cosine of 39 degrees. 1 cross multiplies to 23. Then you divide both sides by the cosine of 39 degrees. And then you'll use your calculator in degree mode to evaluate what 23 divided by the cosine of 39 degrees turns out to be. Okay, Perry, what did you get? Oh, okay. All right, Daniel, you have yours in your hand. What did you get? Okay, 5, did it come out perfect?
No.
Okay,
Well, I mean, 29, 25, 9.
okay, Lucinda, what'd you get? Okay, so we'll get, as long as 2 people get the same thing. Okay, 29.595. So we're always going to go to 3 decimal places of accuracy. So you're going to need to use the Pythagorean theorem tonight when you do your homework if you have 3 sides. And if you've got a combination of sides and angles, then you'll be using SOHCAHTOA as well to find the missing parts. All right? Homework help is still always on Tuesday morning, so you guys have it nice where you could just go straight from getting help right into first period. So start off the semester right. I did not run off your free late coupons, but I'll get you all a free late coupon again for chapter 4. And we're off and running. This semester is going to go just as fast as last semester did. Last semester flew, so hopefully you'll feel like this one's going to fly by too.